Welcome to the Geospatial Intelligence Podcast. My name is Aybars Öztuna and I'm the founder and CEO of Geospatial Intelligence Institute and Master of Science in Geospatial Intelligence candidate at the Johns Hopkins University. Geospatial intelligence, an emerging field. We'll be talking everything about it. Let's begin. Application of GIS in aviation. Scientists and researchers have been dedicated to the utilization of interdisciplinary methods for data visualization. A set of data is required to be processed, and specific techniques are required to be displayed to interpret and analyze complex relationships involved in extensive spatial datasets and to visualize spatial data to build a 3D model. GIS data visualization refers to the presentation of data by digital images, vector data, digital elevation models, tabular information, and virtual reality in 2 or 3-dimensional presentations. Static or animation. GIS visual models assist in data exploration and real-world conceptualization. There is extensive consideration and importance given to the improvement of aerial operation in the airports, both internally and externally. Airports usually occupy a large land for which GIS provides various exploration tools. To improve data management and facilitate decision-making, the GIS applications allow information analysis for the following: efficient and error-free plane management, plane stacking in documents and storage area, a track of scheduled plane times and keeping track of their delays, provide assistance in avoiding the collisions of planes or chances of extreme aviation accident occurrence, reduction and monitoring of traffic on the ground, providing path navigation in case of unclear vision such as bad weather conditions, helps in path analysis of the planes. GIS has the ability to solve various problems taking place in the aviation industry. GIS is extensively used in airports as it provides efficient management alongside providing adequate assistance in managing aircraft storage. It helps navigate the planes when they are operative besides their path movement extraction. GIS also helps in having maximum utilization of land occupied by the airports. Airports need to have effective planning for their external area usage. This importance has led the airports to shed light on their site surveys, master plans, feasibility studies, and management services. GIS technology has helped airports be equipped with all the facilities they lacked previously, resulting in smooth flight operations. GIS in Anthropology. GIS applications may end up being useful when applied to the maps that were produced decades ago. It helps in understanding the diversity of the historical population and why they dispersed. GIS application helps provide knowledge and skills to understand historical maps using a multidisciplinary approach focused on learning the tools of GIS in comparison to working with data from a particular field. It helps to provide a solid foundation to address special questions through the application of special analytical tools. GIS also enables a person to apply predictive in archaeology. It helps incorporate historic map data, physical details of an area's landscape, and known information about past inhabitants. The information collected on the said subjects helps archaeologists accurately predict the site's location with its cultural, historical, or agricultural relevance. This GIS technique was used while analyzing Santa Cruz County in Arizona, near the United States and Mexico border. Archaeologists collected evidence of the area being inhabited by prehistorical populations, which was a motivational factor for them to find further information about the historic population. Archaeologists used GIS mapping to piece together the information gathered from the S-Site Arizona Archaeological Sites database. The U.S. Geological Survey, the Arizona State Land Department, and local environmental conditions, such as water resources. Doing so enabled them to create an archaeological sensitivity map highlighting the most probable locations for ancient settlements, both in areas that were studied in the past and the areas that were yet to be studied and explored. LIDAR application to identify historic settlements. LIDAR stands for Light Detection and Ranging, an application that could be used to employ remote sensing technologies of heritage sites overshadowed by the passage of time. In LIDAR, lasers are used to scan the areas pointed out using historic maps. A beam pans and pulses side to side as it covers the space, collecting information as it goes. The emitters record between 2,000 to 100,000 points every second, and the resulting data helps in visualizing the area as it is operated on. Remote sensing in archaeology allows anthropologists to have a glimpse of the area or landmarks before making personal visits for the said purpose. Researchers had previously used LIDAR mapping to identify anomalies in the forest floor, which led them to uncover building foundations and stone walls that were once used as shelters by historic communities. The advancements in LIDAR technology help anthropologists review 1-meter resolution images and identify abandoned structures. Due to LIDAR archaeology, the researchers were able to uncover New England's historical heritage site successfully. GIS application in aeronautical industry. In the past few years, scientists and researchers have been inclined toward the utilization of interdisciplinary methods for the purpose of visualizing spatial data. It has helped them construct a 3D model involving a dataset with the capability of processing and displaying specific techniques. These techniques tend to provide assistance in the provision of reasonable interpretation and conduction of an analysis based on complex relationships in extensive spatial datasets. GIS data visualization presents data through the means of digital imaging, vector data, digital elevation models, tabular information, and virtual reality in 2 or 3-dimensional presentations. Static or animated. The reason behind constructing GIS visual models is to assist in exploring the data and provide a conceptual mirror of the real world. GIS is just as functional in the aeronautical industry as it is in the aviation industry. National aeronautical offices and institutions, their contractors, and commercial chart producers utilize GIS for the creation and maintenance of quality data in order to analyze standard-based chart productions. Esri's GIS solutions are ideal for aeronautical production because in these solutions, the data is fed spatially, which helps keep its geometric properties intact, enhancing its importance in aeronautical charting. In the aeronautical industry, GIS provides significant help in data creation, editing, and restoration in a centralized manner so that the data can be further used without any hassle. Further utilization or applications of GIS are as follows. Creation of charts, aeronautical information publications, which is AIPs, aeronautical data creation, tasking, and web services. multidimensional visualization and analysis. GIS has the capability of reducing possible errors in editing. It also helps restrict the application of old or irrelevant data, which minimizes the chances of inaccurate data circulation within the industry by providing surety that the data is stored in a centralized location and is not segmented anywhere else. Furthermore, GIS helps in the creation of navigational products through the application of correct data, helping in the maintenance of secure navigation. It also manages an extensive set of obstacles and terrain data, which is later used for electronic terrain and obstacle database, which is ETOD compliance. GIS allows the creation, visualization, and analysis of this data, which provides an authentic workflow, making it easier to incorporate upgrades in Aeronautical Information System, which is AIS, updates much easier. If you would like to have a variety of sources, feel free to follow Geospatial Intelligence Institute.org. That is geospatialintelligence.org. My name is Aybars Öztuna, and this is the Geospatial Intelligence Podcast.